Hello, how you doing? My name is JF, Brandon. My last name is Brandon, my first name is JF. It's confusing, I know. And I'm part of BotFactory. We're from New York City. I believe we're the only American company here. And I want to talk to you about our product called Squink, a desktop PCB printer. I mean, this is clearly obvious to everyone. Printed circuit boards are kind of the core element in every single device today. They are the central core of modern life with connected devices, depending on those elements. They power this presentation, they're powering our machine, and they're incredibly important. Now, of course, our mission is to create, essentially, make it easier for people to fabricate those printed circuit boards. The entire history of electronics has kind of been about miniaturization. Miniaturizing the components, making the boards smaller, making devices smaller and more convenient for people. But we're more interested in miniaturizing the fabrication tools that are required to make those kind of boards because, as you might know, fabricating electronics is incredibly difficult. It's time-consuming. There's a huge budget that's required to make any kind of device. It takes a long time for that board to be sent out because printed circuit boards are literally made in factories designed to make millions of parts, millions of boards, not to make one-offs. And for anyone who does any design, they know the importance of iterating their product, redesigning it, maybe dealing with a customer's change of scope or change of what they're specifying. And that is why we created Squink, the desktop PCB printer. Can I play the video, please? So it's a very small package, 16 by 16 inches. By the way, if you haven't seen it, we're on the booth over there operating the machine right now. XYZ gantry system with 3 interchangeable heads to do 3 separate processes for making a circuit board. You upload your Gerber files or image files. I've drawn stuff and scanned it and printed it. You can even do that. Our software runs on a browser, so you can just connect to it via using a router or Wi-Fi. First step of the process is you print the conductive silver. We use a patented silver nanoparticle ink. Print the conductive traces. It's pure silver, so it's very highly conductive. Second layer is an actual insulating layer with opens to connect the bottom and top layers. So in that respect, it's like a 3D printer. We have another step where you upload a stencil mask file and a syringe full of conductive glue or paste. And the machine deposits very small amounts of this material onto all the pads. Third step, after you switch out the heads, is picking and placing. So our machine can assemble and populate whole boards by taking components from a tray, using a camera to recognize the part, orient it, and offset it, and make any corrections so that it can be placed on the board. And just like that, you can build a printed circuit board in less than an hour. This is something I actually designed and made in about a day. So I think it's much faster and for a much lower cost than you would expect out of any other standard in a PCB fab house. You just cut the video? So we aim to disrupt what is a multi-billion-dollar industry. $500 billion is spent annually on electronic design and development. $5 billion is spent on prototyping. Imagine if we could actually replace that whole market with our machine, capable of fabricating circuits right at your desktop. And we're coming in at an interesting time when parts, the number of products, electronic devices is exploding. Not just in quantities, but in different types. IoT devices, passive devices are sort of a large portion of this explosion of electronic device. So we imagine that we can make a product that will be essentially a must-have item for anyone that designs electronics, but also people that are learning how to design electronics so they can innovate and prototype quickly. The key value propositions of our product are built around three items. BotFactory Squink can save people money, it can save people time, and allows you to protect your IP, the core elements of your technology that might be as part of the printed circuit board. In the time we've been around, we've discovered that there are 3 specific types of buyers. First type is your R&D manager, which is a great number of people here who manage R&D labs, either within large companies or small companies. And their goal is to essentially develop new products innovate and develop new ideas, and they have major constraints in terms of time and money. So by having a product like us, they can actually do some of this. And of course, they also have to protect IP. They are creating, in other words, innovative ideas. They want to be able to protect them, not send them or share them out with other PCB board houses. Professors in colleges and universities, they often have unique projects or ideas. They are creating new ideas, and they like a product like ours because it has dual use, because they can teach electronic design as well. There's a major problem. Getting people to understand how to design a board when you have to wait several weeks, and that might be a long class or a very short class, it might be better to have a machine that can do it right there and then. And the third type of buyer is a makerspace. They have limited budgets, but they're interested in having a product that they can quickly iterate. They can have a tool that has a variety of functionality so they can sort of meet the needs of their membership. They can make money off this by selling time on the machine. We've actually sold a lot of machines to makerspaces where they use that and make money off the services they can provide. Our business model is kind of what you might call blades and razor model. So we sell the machine, and then we, of course, lock in the customer and sell ink and substrates, and even possibly components. We could expand this sort of business model to make Squink essentially a starting point for anyone who's developing a new product. And when they start building the design, we might be able to suggest them products or components that they could use, or manufacturers that could make boards on a larger scale. We are the only company in the world today that sells a product that can pick and place, print electronics, and do all the stenciling in one single integrated product. Our competitive analysis has indicated that there's other companies out there, but they're only concentrating on one element. Like they can print traces, but they can't do pick and place. They can pick and place, but they can't print traces. Our machine kind of has an end-to-end solution. And to my knowledge, we are the only people that have actually been actively selling in the market today. We've built what I would call sort of an A team, a dream team, people with real experience in building startups and making companies and exiting from them. Two of our team members have actually started companies that have earned tens of millions of dollars in revenue and have exited from. We have PhDs, masters, and people from backgrounds like IBM, MakerBot, and Qualcomm. These are a list of notable buyers. These are Fortune 500 companies, Fortune 50 companies, leaders in electronic design and development and manufacturing, as well as about 40 universities and colleges, including Columbia, New York University, and various makerspaces across Western Europe, North America. And these are the sort of bridge list of what people have been using Squink for: embedded systems, wearables, LED arrays, flexible harnesses, interconnects, endless number of applications for this machine. I mean, what would you expect from essentially what is a PCB factory right at your desktop? So since we were founded, we've actually hit quite a lot of milestones, won multiple different awards for our work, including Make Magazine's Launchpad Award, came in second place in the National Hardware Cup in the United States, and we've hit some sales milestones as well. We sold 20 last year, 20 sales in a single month, and we've also raised about $1 million from friends and family to build the product, develop, and accelerate growth. That's it. You have any questions? More than happy to answer them, and our booth is right over there.
Thank you. There's a question.
Sure.
Wait.
In the video, you had the unit placing items down. I didn't see them being soldered. Did you have to come back with a soldering process to finish off, or?
Good point. That's a very good question. So there's a heat bed. So we were dispensing conductive glue in that case.
Yeah.
And the heat, it's heat curable. So we essentially turned on the heat bed, and it cures the material, basically driving off the epoxy and curing the material.
Okay. So by placing them there, it self-solders? Because it's
more or less. Now, if I had a board and I put on solder paste, I would need a reflow oven. Heat bed only goes at 110 degrees Celsius. So you might need a secondary item for reflowing, or a heat gun to reflow the materials.
Thank you. I had a question. When you are doing disruptive, as you call it, disruptive technology, why do you still make a PCB? You could also just mount the components together with a system like this in a 3D way?
Oh, are you saying like printing like boards like three-dimensional circuits?
Yes?
Yeah, that's completely possible with this machine. Basically, what you can do is, because it's an additive system, it's not a subtractive system that uses like etching, which is typically how a PCB factory makes boards. It's possible, and I've been doing this, to print, insulating layer and then conductive layer, insulating, conductive, and build up objects like sockets, headers, things like that. So it is quite possible to build, let's say, elements where the substrate and the sort of elements like the sockets are kind of one piece.
Okay, thank you.
Yeah, no problem.
Any questions in the audience? Yeah.
I suppose when you also place components, you have to stuff the area with the components. How do you do that?
On the bottom left corner, there's a tray with small slots, and you place the components by hand there. And the principal reason for that is to essentially allow us to use a huge variety of number of parts and cut down on the time required to set up a reel system. Tape and reel system.
Okay, then thank you very much, Brandon. Thank you for
very
your
much.
presentation.
Yeah, cheers.
And we will continue with our next startup.